температурного состояния обычно используют экстремальные методы обработки материалов. Потому процессы протекают как за кратковременный период, так и в неравновесных условиях вообще. И стандартного оборудования практически не существует для исследования динамики таких процессов. Вот нами и предлагается использовать метод скоростной рентгенографии, который был
offer to use the high-speed X-ray method, which was reported first back in the 1963. So it's been 50 years since that method has been first used in the Institute of Material Science. There's no standard method, but it is known that the direct method of examination of microstructural set is X-ray analysis, and that's why we would like to apply this method. What is needed? Of course, the exposure should be lower, but how? The core of the method is, of course, using a powerful X-ray, which can be a standard X-ray tube if we're not using the synchrotron. And how to increase its efficacy? The first slit the focal point of X-ray tube, which increases the efficacy in dozens or 100 times. Second, what can be done is to attempt and try a bigger surface area of a sample, a reasonable big. So we achieved up to 100 square millimeters, so 10 by 10. And of course, to use focal camera, a Zellner-Boeing camera. This is the first shot, and again, some corrections should be introduced. This is just a device with the high potential of treating the material. This is not a high-speed X-ray installation. And for potential investors, I'd like to say, don't be scared. This is not included in the cost of the equipment. So this is a machine 1246R, but we added X-ray emitter and the system of registration and processing. And of course, the standard X-ray tube. Still, it has to be there. So basically, this device allows to process the sample, whether it's solid or powdered. And of course, I can show you, this is a detector, a positional sensitivity sensor, and some circuits of amplification and processing. So what's new in this case that we wanted to show to you? Primarily, a very successful use of the sensor to register information in the high-speed X-ray. When we talk about exposure, the standard equipment uses exposure where the slit with the detector is located next to the sample or within the interference maximum distance. In this case, okay, this is a schematic that shows huge potential capabilities of this equipment. So this is sample. This is a focal point of X-ray tube and detectors of X-rays. They're shown, of course, in sectors, but we would like them to be over spread across the whole circle, because we would like them to be within the interference maximum, tuned into a material within the sample. Currently, we use the standard equipment, and we try to add some options: temperature, diatometer without gradient, because diatometer is heated up by current, and of course the movement sensor, since we will study the sintering properties of powder materials. And of course, thermal and so wide complex of characteristics that will be always useful when discussing the properties of material. So difference within positionally sensitive detector is that the time of exposure and the scanning time with high speed is when one X-ray is made, but in this case they are almost equal. So we increase the time resolution of the device. Before we had only 50 X-rays, now we can have 100 X-ray shots, and we will reach the 1,000 or 5,000. So for you to see that it is all indeed working, so here's an example of X-ray. We're in the state of approbation of this detector for high-speed X-ray. We had managed to register the second line. The first line was registered more than 40 years ago. Of intermediary phase. In the recent time, there are publications that prove that indeed we need to recrystallize through hexagonal epsilon phase. This can be expected in other materials as well, but in many cases it's been proven, maybe not so obvious as in high-speed treatment, but I think we will move even further than this. Okay, 2 minutes left. Then I will try to tell you something else. In order to not to scare the investors. And what you see in the picture is not the picture itself. It's the impact machine. The machine itself can be as big as a case, as a document case, with all the parameters that I've told you about. So I think that not only the producers will be interested, or at a certain stage of the process, maybe the scientists that are here will be interested because you are dealing with this kind of structured materials, and I think it's going to be useful to all of you. Maybe that somehow gives me some leverage over your opinions. Now, let's see, 100 X-rays per second, and what a good curve it is. So it's obvious that X-ray analysis and harmonics analysis is very good for analysis of thin crystalline structure. So it is done, we have determined the density of informational defects, the dislocation and energy defects of the package. So it's very exhaustive set of information that we can obtain with the X-ray structural analysis. This methodology is well protected, and I think that even among the scientists there will be potential customers, and we will try and make everything possible so that you have such a device at your disposal. Thank you, Doctor. I think there will be many questions. Okay, is it for X-ray structure or X-ray phase analysis? If it's a thin structure, it's for both the structure and for phase analysis. Of course, it's a huge potential scope of use. You mentioned electrothermal heating. Is it inductional heating? Or no, by current of industrial frequency. So direct contact, yes. Okay, since we have this quoting the popular song of the 70s, is that in small things we're ahead of the big world. But how are you using this? No, synchrotron emission cannot be is it better or worse than the device you showed? In this case that I suggested before, you can even achieve the synchrotronic radiation, because the X-ray ratio is 0.01% or around that. So the device that enables us to use the X-ray or the efficiency of X-ray is 80%. So let's compare 0.01% and 80%. Whereas the X-ray tubes, 8-10 watts, they don't need any protection. And this tube or valve is powered by a portable battery, and it can indeed fit into a document case. At any stage of the process, I think you will be able to apply this kind of device. Could you tell us what is the production cost? Do you have any design documentation in order to license such machines? Of course, most of the institutions would be interested if this machine would be affordable at a price of about $50,000. Why not? 50,000 sounds quite realistic, if only you have at least one detector. And detector comes with a size 14 by 14 millimeters with a 50 micron step between them. So you have to describe a profile of X-ray radiation And the cost of such machine is hard to say. It's hard to tell in a template because it all depends on the what you fit in that machine and the system of registration of recording the sensors, because most of the sensors are produced abroad. And if we take the X-ray machine in Russia, an Institute of X-ray Optics. So if we have $50,000 available, we will come to a reasonable consensus. I guarantee you that.